This series of videos covers the topic of modifying views. Now, I have to admit that the amount of coverage is a bit disproportionate compared to defining and using views. Commonly, people only define views and use them and don't try to modify them in applications. But when views are modified, the issues become a bit tricky, so it is important to cover the topic. First, a reminder of why people use views. They use them to hide data from some users, so for authorization purposes. They make some queries easier. They help you modularize your database applications. And as I've said several times, our real applications do use lots and lots of views. Now, querying views is relatively straightforward, as we've seen. Once a view has been defined and given a name, say V, then in our queries over the database, we can reference V as if it were a regular table. What happens underneath is that when we reference V in a query, it's rewritten to use the tables over which V was defined, and we'll call those the base tables. Those can actually be regular tables, or they can be other views. Now, what about modifying views? Once a view has been defined, can we modify it just like it's any table in the database? Well, in one way that doesn't make sense because V isn't stored, so it's not a table that we can go in and update to insert tuples, modify tuples, or delete tuples. But in another way, it absolutely has to make sense because the idea of views is that some users or application developers are seeing those views as their only view of the database. We saw that three-level idea of databases. We had the physical layer, the disk, the conceptual layer, the relation, and then the logical layer, which again, some applications see as their access to the database. Well, our solution is actually parallel to what we do with queries. When we have a modification command that involves a view V, we'll rewrite that modification command to modify instead the base tables over which V is defined. If those base tables happen to be views themselves, then we have a recursive process of rewriting those modifications to further go down until we get to the base tables that are actually the tables stored in the database. So maybe this is no big deal. We saw in our demo that modifying queries that reference views into queries that reference the base tables is a relatively straightforward process. Well, I'm going to say right up front, it's not quite as straightforward when we're talking about modifications. So let's draw a picture to see what's going on. Let's say we have our view V here, and V is defined based on a query over its base tables. And for now, let's just assume that those are stored actual relations. So it's defined over relations R1 to Rn. Now someone comes along and they want to modify V. Now V is just a logical concept, but the user thinks of V as a table, so they write a modification command. So that would be, say, an insert, delete, or update command using the SQL language, and they're imagining that V is a stored table, so they're imagining that the result of that modification command is going to be a new table V prime. What needs to happen is down here at the bottom, that modification, that imaginary modification to V, has to be translated to actual modifications on the base tables R1 through Rn. So now we modify one or more of the base tables to R1 prime through Rn prime. And now the idea is that our imaginary V prime then is the same query. It's the result of this same query, V's definition, over the new R1 prime and through Rn prime, the updated base tables. So if we can always figure out how to translate this modification up here into the modifications down here so that this square diagram holds, so that the resulting modifications here give us the effect we wanted upstairs, then we're in good shape. So the question is, can we always perform this translation of the modifications so the square diagram holds? And the answer is actually usually yes. Usually there is a translation that works for us, and we'll see some examples of that in our demos. The problem actually is that there's often many such translations, and so we don't know actually which one the user intended. So let me give an extremely simple example. Let's suppose that our relation R, it has two attributes A and B, and our view V is defined as the projection on A of R. Let's say that our current contents of relation R are just one tuple, the tuple 1, 2. In that case, the current contents of our view V are just the tuple 1. Now let's say the user comes along. It's a user who is operating on the database through view V, and they say insert into view V, please, the tuple 3. So we need to translate that insertion, which again is up here, into insertion or some modification on the base tables so that the view will, when we're done, contain the tuples 1 and 3. Well, we can certainly do that. The problem is, what exactly do we insert? We could insert, for example, 3-1, we could insert 3-2, and so on. So there's actually an infinite number of translations that will create the tuple 3 in the view. Here's an even more extreme example. Let's suppose we have a relation with one attribute n, and our view V is the average value of that. So if, for example, our relation has the values 1, 3, 5, then the average at this point would be 3. Now let's say that the user comes along and says, let me update that average. I'm going to set that average to be 7. Well, how do we update the base data so that its average is now 7? Well, as you can imagine, there are many, actually an infinite number of ways to update the base data so that the view average would now be 7. So that's the crux of the problem. How do we decide which modifications to make to the base tables so that we get the desired modification to the view? Correctness is not so hard to achieve, but resolving ambiguity can be. Existing systems have actually taken fairly different approaches to this problem. Again, to specify the problem, we have modifications specified on a view V. We need to rewrite those to modify the base tables so that when we have our view over our new base tables, that reflects the desired new state of the view. One approach is that the view creator actually specifies that rewriting process. So they will say, you know, when somebody tries to insert into the view, here's what we need to do on the base tables. If they try to delete, here's what we do, and update, here's what we do. So the positive of this approach is that all modifications can be handled because the view creator is going to specify exactly what happens in the case of those modifications. The downside is that there's no guarantee of correctness, meaning there's no guarantee that that square diagram is adhered to. And we'll see examples in our demo of where it's not, or even that the translations are meaningful. So we're relying on the view creator to create correct and meaningful translations explicitly. The second approach is to restrict the views and modifications that are allowed so that the system can automatically perform the translation into modifications on the base tables that are correct, meaningful, and unambiguous. So the plus now, of course, is there's no user intervention and the result is going to be correct. The downside is that the restrictions on the view and modification combinations are fairly significant, as we'll see. So the first approach is actually enabled by a type of trigger that's known as instead of. I alluded to those triggers briefly in the trigger video, but here's where we're going to actually see them in action. In Postgres, there's a concept called rules that's very similar. The second approach is actually the one that's adopted by the SQL standard, and the SQL standard gives very rigorous limitations on what views can be modified. Systems vary in what they implement. Most of them are actually a little bit more flexible than the standard, and we'll see that in upcoming demos as well.